All right, so in this question we've got a plane and it's flying in this direction, so that's 41.5 degrees west of north, and they give us the plane's speed, 735 kilometers per hour, and they're asking us to determine the vector components of the velocity. In other words, like its velocity in the north direction and its velocity in the west direction, and they're asking us how far it goes in the north and west direction in 3 hours. So to set it up, well, let's just recreate that vector. So that v vector looks something like this. And here's the vertical component of it. I'll call that v north component. And here is the west component. You could also draw the west component up here. Right, these are the same. And notice they give us this angle here. So I should write that a little bigger. Right, they give us the angle here. So since the north side is adjacent to this angle, right, this is the hypotenuse of our right triangle. There's our right triangle. The north side is adjacent. Vn is v cosine theta. And the westerly component, right, that's opposite this angle. So v west is v sine theta. Now in order to figure out those components, we just have to put this into our calculator. So we would do 735, I'll write out what I'm plugging in. We would do 735 cosine of 41.5 degrees. And for this one, and yeah, that's in kilometers per hour. And then for this one, we do 735 times the sine of 41.5 degrees in kilometers per hour. Those are our units. And if we plug those in, for that one we get about 550 kilometers per hour. Right, that's the north component. And then for this one, we get .487 kilometers per hour. Okay, so there's the north component, and there's the west component. All right, so now for the next part, in order to figure out how far it goes in 3 hours in the north direction and the west direction, well, in the north direction, maybe I'll call, let's just say delta north, right? So that's the displacement in the north direction. That, over time, is equal to the rate at which it's moving in the north direction, which is this. We know the time is 3 hours, so we've already kind of, right, this is already actually in correct units, right? So 55, we could write it like this, kilometers per hour. If we move the delta t here, we know the time is 3 hours, right? So delta north is just 3 times this, which is 1,650. Yeah. Kilometers. Yeah. So that's how far it travels in the north direction. North displacement. So now we need to do the same thing for the west direction. So it's delta west, or it's westerly displacement. This is kind of a weird way of writing it. Right, its west displacement per time would be equal to this. So its west displacement is equal to 487 kilometers per hour times 3 hours. Right, and just notice also that the hours cancels. It also cancels here, right? So we're getting a final answer in kilometers. And if we do that, well, that gets me 1,460 kilometers. There we go.